Yes, perfect. Okay, so what I'm going to, that's what I say. So we have the CDE there, the common data elements, and there are these other type of metadata standard which have been developed by the community, which also have the scope of being descriptors to describe concepts that are essential for interpretation, verification, reuse, and so on and so forth. So practically, there are these three types of metadata standards: the guidelines, the terminology, and the formats the community has developed. Just to give some examples, when I say a guideline, you might have heard of the Miami guidelines. 2001, it's the minimum information about the macro experiment. So it's more a document that tells you which concepts need to be reported when describing an experiment. And those usually guidelines come associated with terminology, so that they tell you, okay, when you describe this concept, perhaps you need to use terms from these vocabularies, or this ontology, or thesaurus, and etc. And sometimes those guidelines also come with an associated model or format. So when you express this concept in machine-readable format, there is an associated model needing to be used along with the terminology. Okay? So this is really to show that there are lots of those standards. You will see a number afterwards. And those are developed both by grassroots initiatives. So like like for Miami, there are many other by many groups, including actually the NCI Technology Working Group developed also this type of metadata standards. And there are so many, but there are also groups which are more like formal standard organization developing similar type of metadata standards. This is in terms of number, to give you an idea that there are thousands of this metadata. More or less there are over 220 biomedical specific data formats, metadata formats. There is over 500 terminologies and ontology and etc. And this is where you can find them actually in BioPortal in terms of a number. And there are over 150, more on the 150 almost, guidelines covering both medical and biological area. You might know CONCERT, ARIVA, and this type of guidelines as well. Next one. So the problem is, like for CDE, that you want to make sure that people use them and know where to find them. The same problem exists for this type of standards. There are researchers, but there are also curator or developer implementing tools that help the researcher to report and share the data that they need to use this standard. And there are policymaker standards, but also journals. Like Anita reported, they need to develop guidelines to point the researcher to the right repository to use the right standards. There are also librarian, data management, etc. And those have the same problem. Find the right standards, metadata standards, which is appropriate for their data type, understanding which one is mature, which one is used, which one is not used, which database use which standard in order to use it or to recommend it. Next one. And that's the reason, the use cases behind the BioSharing portal that we created several years ago, and we are running in our group. And it's also linked to Elixir, which is an infrastructure for bioscience actually in Europe. So practically we have registry of standards, registry of databases, registry of policy. We don't cover CDE, we cover these other types of standards that I mentioned before, search functionality, and etc. If you go to the next one, what actually is BioSharing is a web-based search for curated portal where we describe the standards, link them to the database to understand which ones are used and how they're used, and also we register policy from journal and funder to understand which of these policies recommend databases of standards, to understand the entire landscape. So practically it's the relation between the standards, the database, and the policy what we do, but we also link the standard among themselves, and I will show you why this is essential in the slide after next. What I want to show you here, that what we do, the reason why we curate these standards, which means the record that describes the standard, who runs it, when it's run, if they have a help, if they have training material, and etc. It's also important because we want to understand the status of the standard and the status of the databases. Are they ready? Are they mature? Have been deprecated? Have been superseded by another one? So tracking evolution is also what we do. And we use specific tags to define if a record indeed is the standard is ready or has been superseded or is in development, etc. And to work with the community which is behind that standard or the database. So, but we also work with journals, and I'm glad that Anita brought this up, the importance of educating people, especially those which are developing data policy. And journals are developing data policy. Recommend their authors to go to a certain database to deposit the data, but they also start to somehow recommend standards. But they do not know the landscape. They do not know which one to recommend. They don't know which one is mature. They don't understand the relation among them. Fair enough, So we help them. What we do, we work with many journals, with PLOS, with the Springer Nature, and everybody who has data policy, and there are many journals who have data policy. There are fewer, but the number is growing. What we do, we represent their data policy in BioSharing, and we can also, because we can show it graphically. So here you can see the number of databases in standard which are recommended by the EMBO-Press data policy. But the editors can also see the relation between the standard and the databases, so they understand what they're recommending. And I'm saying that. Oh, one back. This doesn't show up. I'm sorry. So what you don't see here, this is why I'm liking the policy from PLOS. It's because here there is a lot of lines which are actually gray that links this database with this standard, and they're light gray because they are not. The standards are not recommended by PLOS. PLOS only recommends these databases. But recommending the database that implements a standard, somehow you are implicitly recommending the standard behind the databases. So we try to educate, again, in this case, is the journals to make the right recommendation and extend the data policy as new standard, new database become relevant or become mature in a certain domain. What I want to now explain you very quickly with an example, why it is important to relate standard among themselves and standard for databases. And then I'll try to make a comparison between this ecosystem and the CDE. So, go next. So there are two databases, GeoNCBI and ArrayExpress and EBI. Both have gene expression data, transcriptomics data set. Both repositories implement a standard, a guideline called Miami. Okay, next one. The difference is that Geo implements the Miami concept with two types of formats, minimal and soft. To go next. ArrayExpress does not use the same format, but they still implement the Miami concept with two other types of formats, MageTab and MageML. But what's also important to show to the user that MageML is now deprecated. They no longer support it, and they've been replaced by MageTab. To go to the last one, what's also important to say that while Geo does not use any control vocabulary, ArrayExpress MageTab format requires certain concept to have a certain value from an ontology called EFO. So that's why it is important to represent all of this, to educate research or any other people how the standards are being used. And I want to make a comparison, and I thank you very much, Mary Cooper, during the discussion to make it clear to me that in a way, in my opinion at least, Miami represented the concept. MageTabs represented the order of the concepts, and EFO represents the value for certain concepts. So this is like a form in CDE. Hey, so to me, I was trying to find a correlation, but that's, it is a different way of doing it, but it's not that different if we think about. That's why it is important to understand how they're used and how can be used in order naturally to make sure that the researchers do use it. And I'm almost done. I've analyzed a problem with this standard in this number of standards. And I think you might have the same problem in the CDE area, but I don't know. Because of this standard has been developed by community from a certain viewpoint, from a certain domain. So people from the microbiology or plant biology came up and developed their minimal checklist, terminology and format from their viewpoints. Then we had community who assembled the steps because they were working on metabolomic technology or proteomic technology, and they developed the standards, again, the checklist formats and control vocabulary coming from the other viewpoints. The problem is, you wish that everything were Lego pieces, that you can combine them the way you want to describe any type of experiment that maybe has one or more technology and one more type of sample, because there is a lot of elements that describe the source of the sample, the design of the experiment, or maybe the treatment, which are very common, but this is not the case. If you go faster, actually, one more, yes, I'm going to show you this. This is an example. I'm going to try how I actually explain the problem. If I want to actually try to represent an experiment which is about gut microbiome and profiling it, and my experiment is proteomics-based experiment, but then I have another experiment which is also a gut microbiome profiling, but I'm using proteomics and metabolomics technology. I wish that the element that I need to use to describe these two experiments were the same, and I assembled them to represent the two different types of experiments, but I'm using the same Lego pieces, the same concept, the same CD, perhaps a different value set. That's the way you say it in CD. But unfortunately, it's not the case in here. So go ahead, and this is the really very last slide, because this is one of the work we are doing in BioSharing, also as part of the CEDAR project. So practically, one BioSharing, you register just the standard, how they all record and etc. We'll be testing. We find a method where we work with the community to make those standards machine readable. We extract the element, and we find the common Lego pieces. So this is a very simple example where I have two checklists. One covers environmental sequencing. One covers just any type of sequencing. And those checklists actually are used by the Sequence Read Archive. But you need to know which concepts are relevant to your experiment when you submit it. Now, if we unpack this standard, we find that, things like sample information are common, of course. So the idea is to unpack the standard and ensure that we can track the provenance of each metadata element from the corresponding, standards, so that we know that these elements here actually is common to many of those checklists. And this is a work in progress. And the idea is to serve them from the BioSharing website, and that's actually, because my last slide is an acknowledgement with several groups we work with. And I also want to say that Mike West sits on our scientific advisory board, because we want to make sure that he's kept abreast with what actually we do, so that we can try and find commonality with other efforts, especially within age. Thank you.